Hello everyone, welcome to my programming club. Today we will be solving another daily lead code problem and problem's name is dot vowels in a string. Okay, so you are given a zero indexed string s. You have to commute s in such a way that it will generate a new string following these constraints. All the consonants in the new string will remain on the positions on which they were in the original string. Okay, so the consonants places will not be changing in the new string. Only vowels places will be changing in the new string, and they will be sorted in non-decreasing order of their ASCII values. So, for example, let's say let's take one of the sample test cases. And those of you who forgot what vowels were, they are the letters A, E, I, O, U. Okay, and they can appear in lowercase or uppercase. It is also given. Not only lowercase or uppercase letters, a mixture of them can be there. So this is a sample test case. Okay, so this is the string. So what places will be remaining as it is? This L, these both are vowels, so we'll be changing that. And T will remain as it is, C, and then D, rest all will be changing. Okay, so these places will be ordered. Okay, so E is occurring twice, small e, then capital E is occurring once, and your capital O is occurring once. So we will sort this according to the ASCII values, and then we will change their places. So the changed string will be, since if you want to find ASCII value of small a, I think it's higher than the capital A. Anyhow, let's check. Is 65, and if you go on for capital A, I think it should be lower or higher. Capital A is also 65. It should not be the case. Yeah, as you can see, for lowercase a, it is 97. Okay, so it's higher for lowercase letters. That's why uh, in this particular string, uppercase letters are given the preference. Uppercase vowels are given preference, and they are appearing first. Okay, so uppercase ones are having lower ASCII values, so they will appear first. Okay, and these one will be having higher ASCII values. And if you see what was the value, 97 and 65, I think it was. So 97 plus 26, okay, and 65, 25, if you take all the letters up to Z, and 65 plus 25. So I think 256 characters would be sufficient to cover all the 256 is a sufficient number to cover all the SKY values. So how we will be approaching the problem is, first of all, before arriving at a solution or thinking about a solution, let's have a look at the constraints. The length of the string will be of order 10 raised to power 5. Okay, so a sorting solution can work out here. It will be n log n if you really want to apply the sort. But I don't think sorting is necessary here. What we will be doing is we will be opting for a two pointer approach. And a kind of, you can say, mm, frequency count approach plus frequency count. Okay. Now to count the frequency, what we will be doing is we will be taking an integer array. Since ASCII values will be ranging from 0 to 256, ASCII values of input string. Okay, so you can take an integer array of 256 size initialized with zeros, and name it frequency. Okay, character frequency. So this is one thing that you will be doing. It will automatically maintain your characters in increasing order, and you will count the frequency of only vowels, or you can say instead of character, vowel frequency. Okay, so vowels will be maintained in increasing order. Then what you will do, you will take two pointers. Let's say your given string is str. This is given to you, and this you will form. Okay, so one pointer will be pointing to this particular array character frequency. Let's call this frequency pointer, and let's call this one as string pointer. Okay, so what you will do is whenever you will encounter string pointer is pointing to a vowel, whenever string pointer is pointing to a vowel, and your frequency pointer is pointing to a non-zero value, then you will insert Let me change the slide. Uh, insert or you instead of insert, appropriate word will be replace. The vowel at string pointer with the vowel uh, your vowel pointer is pointing to frequency pointer. And what you will do is you will decrement the frequency of the vowel that frequency pointer is pointing to. Decrement frequency of vowel that frequency pointer is pointing to. And in case it reaches 0, you will move the frequency pointer ahead. Okay, so frequency pointer will be moving ahead, and as soon as you do a replacement at string pointer, then you will constantly be moving string pointer ahead. Irrespective of the case whether you have made a replacement or not. Okay, so let's take an example. So if you take the example of this particular lead code, E will appear first and then O and then this E. So the order will be like E, O, and then small e. If you go according to their ASCII values. Okay, so it will be its frequency will be 1, its frequency will be 1, and its frequency will be 2. So your 256 characters other than that, 256 minus 3 characters will all be zeros. Okay, and these ones will be there only. Let me highlight them. 1, 1, and 2. Okay, this is your frequency array, vowel frequency. So a pointer will be pointing to these vowels right from the very beginning. Okay, and one pointer will be starting from here. As soon as this pointer reaches a vowel, and this pointer reaches a non-zero value, you will do the replacements and decrease this count, decrease this frequency. In case it reaches to 0, then you will move this pointer to a non-zero location. So you will keep repeating that. move to non-zero. Okay, move to non-zero location. So E will be 0 and you will do the replacement here. It is already E, so you will move this pointer to another non-zero value. It is the non-zero value, next non-zero value. And this pointer will also be moved, so the next non-zero value is O. You will do the replacement and increase the pointer. Then you arrive at a vowel. You will stop here. And this will be pointing to the next non-zero value. Okay. And this time it will be pointing to E. So E will be inserted here. And you will return this string. Okay. And you will be decrementing the value of E to 1, not returning it. Then you will arrive at this E. So the value of frequency is 1. So the pointer will not be moved, and here at last the value of this frequency will be changed to 0 and pointer will be moved ahead, and anyhow you are at the end of your string, so you will return. Okay, so let's quickly implement it. I know it's taking a little longer to explain, but the implementation is really simple. So let's implement. Let me change the language. For vector can be made, and let's name it oval frequency. Let's take 256 its as its size, and this will store frequency of vowels in increasing order of ASCII values. Okay, and actually 256 is also not required. You can have smaller values than that, but I think 256 is indeed required since lower and English uppercase letters both will be appearing. So uh, then you will be populating this vowel frequency. Or say vector. We will be doing one traversal. Okay, so vowel frequency, current character, and increment its frequency. Okay, and then what you will do is the next step will be to take the two pointer approach and start doing replacements. Okay, so I think it's not mentioned here that we can't modify the original string that is given to us. So yeah, there is no such mention. So let's modify the original string or itself. So let's declare two pointers. One will be frequency pointer. It will, or you can say frequency index if you may like, since it will be pointing to the index also itself. So, and another one will be, let's take it simple index string or string index. We will take it in for loop. Int string index from 0 to string index will be ranging to the size of the string. Okay, and string index will be incremented. So while your, let's point this frequency index to a non-zero value. Non-zero frequency value. So while frequency index is lesser than 256 and frequency index correct a vowel frequency at frequency index is 0. Okay, then you will, till then you will be incrementing your frequency index. Okay, now what you will do is, if let's declare a function is vowel. So if your current character is a vowel, instead of function you can also declare it here, but a function will be a more verbose thing to do. So here is vowel, it will return true if the character is vowel, and then if it's a vowel and your frequency is greater than 0, vowel frequency index, it will be pointing to a non-zero value actually, so we need not to have this check. Just a check whether this current character is a vowel or not will be sufficient. In that case, you will do the replacement. Do the replacement in case current character is a vowel. So if current character happens to be a vowel, we will be doing the replacement. So the replacement will be string index character, the string index will be changed. So it will be frequency index casted, type casted to a character. Okay, and you will decrement the frequency of this particular vowel in your frequency count. So vowel frequency index minus minus. And in case if the current vowel frequency, you can make decrement this value while checking also. So if it happens to be greater than 0, uh, lesser than 0, less or equal to 0, first of all it will be reaching to 0. So in that case you will be representing, you will be incrementing your frequency index. And yeah, I think that's pretty much it. Now let's return the thing that is given to you. And before submitting the solution, let's declare a function is vowel. Boolean is vowel. Character will be passed. So if this character happens to be a vowel, then you will return true, else you will return false. So uh, return character is equal to A, character is equal to E, character is equal to I, character may be equal to O, character may be equal to U, and uppercase letters also, capital A, character may be equal to capital E, character may be equal to character capital I, and character may be equal to character capital O, and then at last it can also be equal to capital U. I think that's pretty much it. Okay. If any of this is true, then you will be returning true. Otherwise, you will be returning false. I think all of the cases are covered here. So let's have a quick look to see if we missed anything. So what we will be doing is, firstly, frequency of each vowel will be counted in these two steps. Okay, and then you will be taking two pointer approach. This frequency index will be pointing to the vowel frequency array, positions in vowel frequency array. And firstly, we will make it to point to a non-zero value. Then we will use another pointer whose name is start index, string index, sorry. And then if the current character in the given string is a vowel, then you will do the replacement and you will decrement your frequency. And in case your frequency reaches to 0, frequency index will be incremented. Okay. And it will be made to point a non-zero value. Point frequency index to a non-zero frequency value. Okay. So this will be the case. And then you will return your given string. Uh, Return your given string after zero or more modifications. Zero modification in the case it's already according to the rules. So let's quickly submit it for the sample test cases. Okay, it's giving some kind of error. Okay, we did a typo here. Return as it should be. There is again a compilation error. By mistake have deleted this brace. Now here D is opening more than okay. While counting the frequency of these vowels, we should have included only vowels. So a little mistake here. Uh, if current character is a vowel, then only we will count its frequency. Yeah, as you can see, it's getting accepted for sample test cases. Uh, so if current vowel, current character in the given string, character in the given string is a vowel, then only increment, then only count its frequency. Okay, so let's try for the uh, all of the test cases and do a final summation. As you can see, it's getting accepted. So this is how we will be solving the problem. And if you may ask about time and space complexity, time complexity wise, it will be taking you O n, where n is the length of the given string s. And space complexity wise, if you may ask, then it will be order of, if you are not taking this into consideration, this is just a constant space that will be used here. You can say order of 1. So if this 256 space is not taken into consideration, if you are ignoring the frequency, vowel frequency array. Okay. So if you are having any doubts or any queries in general, please feel free to ask them in the comment section. I will be more than happy to answer. Thank you for watching. Have a great day ahead.